This is Cold Start.
I heard the other day that you finally jumped into the world of autonomous vehicles or autonomous driving firsthand and having your very first drive, I guess, in an autonomous vehicle, if we can call it that.
Is it a ride or a drive? Yeah, I've been a holdout for quite a while, as much as I've been exposed to this stuff from really early on. And it was a friend, we were going somewhere, and it was just last minute, and the circumstances allowed for it. And we said, let's give this a shot. Why not? We have a 5-minute ride. Let's see what the robot can do.
And San Francisco, Waymo, for, I guess, maybe people across the country that aren't familiar with Waymo, what are we talking about? So in San Francisco, it's become a pretty big deal of these self-driving. There's no driver behind the wheel, and they're old Jaguar I-Paces is what they're called.
Yeah, I-Pace Jaguars.
And they're fitted with a bunch of LiDARs and stuff on them, and they can self-drive. And Waymo as a company, for a long period of time, was testing and trying to get into these waters of autonomous driving. And I even remember times going into San Francisco, and you'd see whether it was the Jaguars or even like Toyotas with some stuff on top of them, and you could see Waymo on the side, and they were just clocking in hours and miles trying to like tune these cars. And nowadays you can see them. I think they're in like Austin, Texas and other places now. They're starting to outreach, but I've never ridden in one. I've seen them all the time, but never experienced it firsthand.
It's one of those things where you kind of wonder, how early adopter do you want to be? Because if something goes badly, okay, fine, you're on some website, you hit reload, everything's okay again, or you buy a product that doesn't work, you return it. No, you're going for a ride with a driver who you can't talk to or interact with or control in any way. You're just stuck in this thing, right? So it seems a little bit precarious, a little bit like, let's work the bugs out before we go try it out or jump right into it. And there have been some early examples of where the Waymos, or any self-driving vehicles for that matter, but didn't handle some case well. And you would definitely not want to be the passenger inside the vehicle at that time. So I'd been sort of hanging back to see how all this goes for a while. Meanwhile, Waymo, Alphabet, Google, whomever, have been racking up kind of millions of road miles, gaining experience and working out a lot of the kinks in these systems to the point where they work pretty well.
In the beginning, weren't they like free to try to like convince people to get in the cars and ride? And then from there, like once everything gets said, now it's kind of like basically an Uber. But how did your experience go of like, what was it like downloading the app, calling up a Waymo, jumping in, jumping out? What was the full experience like?
Yeah, well, it was a little more complicated than I let on initially because, well, just to say, I'm not an early adopter for technology generally. So in order to install the Waymo app, I had to upgrade the OS on my phone first.
Which is always a fun process.
Yeah, that'll take 5 minutes, right? What could go wrong? So an hour later, my phone finishes rebooting for however many times and is updated. And then I can finally install the Waymo app, which I do. And I connect it up to my Google account and payment method and all that kind of stuff that you could expect. So I type in, the address of where we were going. It was a concert at the Palace of Fine Arts here in San Francisco. And so entered that and it figured out our pickup location based on where we were. And we waited. So we went down to the curb to wait for this vehicle, and it says it's approaching, and around the corner comes the Waymo, and it pulls up and parks. And on top, there's a little display that has indicators of, I don't know, its status or whatever. And it shows my initials up on top. It says TC. I'm like, oh, this must be my car. On the app, the interface changes where there's a little unlock button now. So I press the unlock button. The door handle pops out. I'm like, oh, I guess we can get in now. So I go grab the door handle, open up, and we get right in. The car inside is very nice. I mean, it's a Jag, so it's about what you'd expect. It looked like they maybe retrofitted the interior. The upholstery itself seemed like super heavy duty as much as it was nice leather.
Like cab style?
Yeah, it was definitely something that was set up for like a lot of wear. But the vehicle itself was really clean. We get in the back, obviously. The passenger's side on the front seat is available for another passenger or rider, but the front seat is not available for an occupant. So there is a steering wheel and there are pedals, and it moves while you're driving, which is a little creepy, but you can't sit in that seat, and there's a little warning on the steering wheel itself that says, don't touch the steering wheel, basically like, yeah, we got this.
It's almost like in like worst case scenario, if someone needs to like jump in to move it, like all of the controls still work. I've seen instances too on the internet of like people having issues with a Waymo or whatever the case is, and like if you contact customer support, they can like take control of the thing remotely.
Yeah, so there's a console in the back. So when you're sitting there getting your ride, or when you first get in the car, there's a display where you hit start ride, or you can interact with the car to change the temperature if you want, or you can put music on if you want. You can connect up your music player on your phone with Spotify or YouTube Music or whatever. And, as soon as you enter the car, it can start playing your tunes. It's kind of cool. So the way by which you interact with the car is through this screen or through your app. And if you have a problem or you need something, there's a button. You can reach out to support. They come on the mic. There's a system that says the mics in the car are turned off unless you contact support. That was something I was wondering about was, are they listening to our conversation right now and mining all this data for marketing benefits or maybe even feedback on how well their service is working? There's a lot of data collection that's going on in these cars. So I was kind of a little maybe paranoid even about, are they going to record our conversation? They know there's cameras inside the vehicle looking at you, making sure you're following the rules, not making a mess, not doing anything in the car that they're going to follow up with you after the fact. So got in the car, got my bearings, pressed the button to say start driving, and the car was on its way on our path.
And with that, what was the ride like? Was it kind of nerve-wracking at first, obviously, of you're not in control and there's no one behind the wheel? It's got to be a weird feeling of being in a car that's not driven by a human because we're so used to that. But what was that feeling like? And then also, what was the driving style like? Was it pretty confident? Was it pretty conservative? Was it kind of I'm not feeling too trustworthy of this thing?
Yeah, the first time's a little unnerving. You're going to pay more attention the first time you get in one of these things. And I was certainly curious to see how it dealt with pulling out into traffic and coming up to a stoplight or something like that. I'd say the car's fairly conservative. At a stop sign, it makes a full stop. None of these, what we call California rolls or stoptional like we have around here, people kind of roll through. No, the thing fully stops at the stop sign to the point where it's okay, you made your stop. Now you can go again. However, when the thing would start going again, it would get up and go. It didn't just kind of lollygag off the line. It used that electric motor and it started right back up.
Yeah.
So I was pretty impressed with its acceleration that way. And there were a few times in traffic where it made what I wouldn't say is a daring move, but it made a more aggressive move than I expected to change lanes or accelerate or something like that. Overall, I was pretty impressed with it. Now, I've been observing these vehicles as an individual car driver or passenger in other vehicles around San Francisco to the point where I've been watching these cars.
Yeah.
And they started out really conservative to the point where they were getting in the way more often than I think they were actually a benefit. They would get stuck in intersections. They would make strange lane changes. They would signal and not get over. I think they've improved this even in the time that the system has been in place, maybe just over a year or two in San Francisco. The cars are much more aware of how to drive in a city, of what kind of weird little edge cases might occur where there's a delivery van that's double parked in the bike lane. There's a car that's not completely within their lane. They're hanging over a little bit. The car seems to be pretty adept at dealing with those circumstances. And when you're looking at the console sitting in the back seat, you can actually see the LiDAR display. So it's kind of cool. As you roll up to an intersection, you'll see the traffic light, the other cars, you'll see people crossing the street, pedestrians, people with dogs. All of that's visible to you in a way that's pretty cool. I mean, you don't get to see a real live feed of LiDAR most of the time. I mean, most of us don't. So having an opportunity to see that is pretty illustrative of what the car is using as input for how it makes decisions.
And I'm sure that helps you build confidence in seeing what the car's seeing. I'm getting a better understanding of this technology. I'm sure there's a lot of people that have never heard of LiDAR before. We've heard of lasers and radar, but LiDAR is kind of this new term that's been coming out with the implementation of that technology for autonomous vehicles. And it's basically like a radar system, but it's a little bit more accurate because it uses lasers. And it can determine the density of objects.
That's exactly right.
And so it can tell if it's a bush versus a wall versus a person. It can distinguish those things. It's pretty impressive. And so seeing a live LiDAR display, I think would be really interesting. I would be curious to see that.
Yeah, it's pretty cool technology. LiDAR is light detection and ranging, which is to distinguish itself from radar, which was radio detection and ranging, right? They've been using for a long time in that technology. So this allows us to, in the sort of visual medium, gain additional information, but beyond what human vision can see, right? To your point, we can see through objects, or we can see through obstacles that might not otherwise be, visible or rather transparent to a human looking. So the LiDAR systems have an advantage over a purely visual system in which There's things that you can't necessarily see, or the conditions prevent you from seeing, where a LiDAR system can still detect those things and make decisions based on them. So that's pretty cool. A lot of the technology in this space is a combination of LiDAR and camera. And I don't know if the Waymo systems also use cameras for detection purposes. I'm confident that they use cameras for other purposes, but I don't know how much of that is used for the navigation itself versus the LiDAR. To contrast, there are other methods that are purely camera or visual-based methods for autonomous driving. Tesla is probably the most well-known for having their system where they base on a pure vision system that's all camera-based imagery. There are no LiDAR sensors or anything out there that's picking up anything other than what can be visually seen.
Yeah, and I think, the people that have been studying the autonomous, because autonomous vehicles, there's kind of two parts to it, right? There's the hardware side of it, which is data collection,
yes.
Sensors, cameras, LiDAR, whatever you need to analyze the environment. And then there's the other side of it, which is software, which is developing, whether that's AI or whatever the program is, to analyze that information and then make decisions.
Right.
Now, I think the experts say that the best for sensors is every sensor you can have. So
yes.
It's a combination of LiDAR with cameras, because there's benefits and downfalls to both of them. I think LiDAR covers a little bit more of the benefits and cameras have a little bit more downfalls, but a hybrid of those two, I think, is the most coverage that you can have. I mean, the more information you can give these systems to make decisions, the better. Now, going into the Tesla case, because Teslas are fully reliant upon just cameras. That's the only experience I have with an autonomous vehicle.
Right.
So I've never ridden in a Waymo. I've watched the Waymos. Mm-hmm. I've seen the development of the Waymo's driving style, like you were alluding to, of in the beginning of driving through San Francisco, you'd see them every once in a while, and you're like, God, this thing's in the way, or it's turning on its turn signal, but it can't make a decision. You're like, man, those things seem so clunky. And then even recently, in the last couple of weeks of going through San Francisco, I experienced a Waymo going into a roundabout. And unlike a human being that would have hesitations, because us Americans are unfamiliar with the concept of a roundabout and how to get in and how to get out and who has the right of way or whatever the case is. But I was approaching this roundabout and I saw a Waymo approaching from the right-hand side and did not hesitate, didn't break a beat, just cut right into the roundabout, didn't cut me off. It was probably I would categorize on more of the aggressive driving style versus a conservative. If it was a human, I would have expected them to stop and let me go through the roundabout first, and then they would have gone. But this Waymo, detected everything it needed to, didn't cut beat, straight through the roundabout, and I was solid. I was respect to the Waymo. That was pretty impressive.
It's pretty cool. I mean, if you think about the potential of where all this extends, the Waymo car should be able to do things that humans can't do reliably, consistently, every time with greater precision. So the fact that a car can kind of weave into an open space into traffic, for a human, it's like this daring thing that we just jam ourselves in last minute to do. For the computer, it's an algorithm. It's a decision. They calculate trajectory, velocity, opportunity, and they make the decision, and they do it or they don't. It's really straightforward. And I think part of the potential of this technology, and we'll talk more about this, but is how do these vehicles together, along with the infrastructure, work in such a way that we can really take more advantage of what they can offer than how we're maybe thinking about the problem as automating cars in the existing world.
And before we get into that, going back to the Tesla case, because I think that's for people out there, when they think about autonomous vehicles, self-driving cars, Tesla is kind of the first and foremost that people think about. I think Tesla was the most daring in this space to kind of take on the liability of giving people access to have their cars drive themselves. And in the Tesla world, it kind of came in two phases. Mm-hmm. And we'll get in a little bit later of the actual phases of autonomy of vehicles. But in the beginning, everyone was like, oh, the self-driving feature was when you had the self-driving cruise control on the highway. Right. And basically it just, took control of the steering as well as the speed control of the vehicle. And you could also change lanes. If you put on the turn signal, it would detect if you had a clear lane and it would move over. But basically, if you wanted to get off the highway or whatever the case was, that system would then turn off. It was only good for cruise controls. But now, Teslas have developed further and they've increased their autonomy, where Teslas do have the capability as well. If you have or pay for the subscription or however Teslas work, I don't really know it. I borrowed a Tesla and I tried out this feature. But you can now, from a parking lot, implement a address the car will designate a route like it normally would for GPS or navigation, but then you hit start and the car will fully drive to that location without you having to engage with anything. So it can make decisions, turn, stop, do everything on its own, kind of like the Waymo situation.
Right.
And so I had a buddy who had one of these cars and it had that feature. I'm like, I've never experienced it. Let's see what it's about. Now, I was a little nervous in doing it, but I was really impressed of how quickly you build the trust with that system.
Right.
And so this Tesla would jump on the freeway, would get up to 70 miles an hour, which was 5 over the speed limit. I was impressed of it's not going to be in the way of anyone else. And even when it would come up on a slower car, could make the decision of okay, I'm going to put on a turn signal, get into the faster lane. I'm going to keep my speed up. Got off the freeway and then navigating the town stuff, which you think would be more complicated. So I was really interested of how I was going to handle 4-way stops, traffic lights, all this sort of unique situations that can occur. And I was really impressed of it really took opportunities when it saw them. It didn't hesitate. Even at a red light, it took a right on red. Came to a stop, I'm going to analyze the intersection, I'm going to go. And then coming up to a 4-way stop where other cars showed up, I was okay, this is going to be really interesting of how does it know when it's turn? Did it really detect when all those other cars stopped? And it did an amazing job. It waited for its turn and it went. And it was there was no issues that I experienced during my ride. I'm sure the further you put these cars through complicated situations they've never seen before, you could find hiccups. But I was really impressed, even with Teslas only having cameras, how good and solid that system was. I mean, I'm not a big proponent of autonomous driving. I want to drive cars, but I don't want to drive cars in traffic. And this system, this is brilliant. It really impressed me of how far these cars are nowadays.
As people who like to drive cars, there are definitely circumstances where driving is a chore. It's not fun to sit on I-5 and just go a slower speed than you'd like to be driving for an hour and a half and just have to constantly be keeping your speed in check and dealing with slower vehicles. And it's a grind. So having the autonomous vehicle capability to take that over sounds pretty fantastic. And you can imagine for the people who don't like to drive, they think this is the best thing ever. So
right.
This is coming whether we like it or not. And so it's a matter of figuring out how to embrace it in the way you can take the most advantage for your circumstances and you use a car in a way you want to use it. So one thing that we've talked about is how Tesla is sort of an outlier in using only cameras for their autonomy technology versus Waymo or Zoox, I think, is the Amazon play, or the GM one that was around a while. They were all using LiDAR and some other sensors. There is something to be said for what happens when the communication system breaks down. What happens when there isn't a central authority to rely upon for making decisions? And I think a lot of these systems that we think about, we sort of draw analogies to the other ones that we're aware of. So in cloud computing, right, everything goes to some central place to be stored or retrieved or decisions to be made, and then it comes back down to us. Well, that seems like that would be really bad and probably have a lot of delay or latency in the system if we were trying to do that with our cars. So the car needs to be able to make its own decision locally, independent of other circumstances. And LiDAR and cameras are neutral in that way, right? They're ambivalent to the information coming in or what else is going on around them. However, there are occasions where the combination of this data, of what a camera can see and what a LiDAR can see, is greater than what any single individual sensor is going to be able to pick up. And the goal here of being able to create autonomy, we call it intelligence. We know it's not really intelligence, but for these cars to be able to make decisions in circumstances that are maybe hard to foresee, we need that know-how, that capability, that ability to make the decision locally without relying on some outside party. So we've developed these technologies where, the AI, the models that we push down to the cars are kept local, but can be trained based on the collective set of information being derived from all those cars. So all the cars driving all the miles on all the streets every day are picking up a lot of data. And that data is coming back to that central place for it to be used for training, for learning, for algorithmic purposes, and then fed back down into the individual car so that they can use that as sort of their instruction set, if you will. So when things happen on the roads, and something else that I think is important to consider here is that the rules of the road sound like they're hard and fast, and a rule sounds like something that always is or always isn't. But to your earlier point about making a right on a red or going 5 miles over the speed limit, right? We all recognize that there's the rules, air quotes, And then there's the rules of how we actually operate, and they're not always 100% the same. And it would be a travesty. It would actually be a really huge problem if computers went out there and said, it's all or nothing. You must or you must not. It's a red light until it's a green light, and you only go when it's green, and you stop when it's red. And there are circumstances where we do things different than that. And the cars need to learn how to be able to do that, to interact with human drivers who are also out on the road. This will be the case for a long time, where we're sharing the roads between autonomous vehicles and human drivers, and hopefully forever. But you could see a future where autonomous vehicles become the dominant vehicle on the road, and they start to take more and more of the infrastructure for that purpose.
Yeah, and I think with that whole transition that could potentially occur, and like we're car enthusiasts, and I think we got to put this in light of, for car enthusiasts, is it like they're going to take cars away from us, of saying that robots can drive them better, so we're going to force cars to be autonomous. Mm-hmm. Does that kind of change the way as us as enthusiasts can engage with the cars? I don't think it's that dire. Once again, like we were talking about, there's certain circumstances that like driving a car isn't rewarding, isn't fun. Like driving through downtown San Francisco, I'm not like, oh, I really need to be behind the wheel because I'm just getting everything I want out of this.
Right.
No, right? Like cities, I think, are the first place where implementing autonomous vehicles makes the most amount of sense. Like you could see if like all of San Francisco is pretty much, 80-90% autonomous for moving people around. Think about it in general, like people don't like to drive in San Francisco to begin with because of how big of a pain in the butt it is to park your car, find a place, whatever the case is. So like
hills, one-way streets, yeah.
Exactly. It's chaotic and it's stressful.
Right.
Most people don't want to be driving in high, dense cities. And so I can see autonomous really being implemented there. Same thing of like maybe big, long interstates where there's not a lot of variables or factors, and it's really easy to make a car drive itself on like a really long stretch of straight highway, because there's not much for it to do, there's not much for it to analyze, and you have these beautifully painted lines that it can stay within. And once again, as a driver, that's not a place where I'm like, yeah, I really want to be behind the wheel and have this thing at cruise control sitting at 80 for 5 hours. Like, if someone else could do that for me, that would be lovely, right? And so, like, as a car enthusiast, I don't think we should see autonomy or, like, autonomous features as this big evil enemy. I think it's going to, like, take over in places where driving a car sucks. And, like, we can admit that there's times when driving sucks. And, like, we know as enthusiasts, save the manuals, but like I don't want to be stuck in stop and go traffic in a manual transmission. Just like if autonomy can take over being in stop and go traffic, oh my God, that would change your life.
100%, right? And this is one of those, what is it that you want and what is good for everybody circumstances where we can make these decisions together and maybe get the benefit of both good outcomes. Driving in that circumstance. Imagine if we can pack cars on the highway as densely as we possibly could, so that they could move at high speed, but they are so close to each other because the decisions that they're making are controlled by the autonomy software, where a car wants to suddenly change its direction. Well, hold up. Before we did that, we knew where we were going. We knew how long we had to go for to get to that point. We know at what point we're going to make a deviation on our course. So why do anything different until you need to? And if all the cars, and this is where we need to develop to, but if all the cars start being able to communicate to one another, there's a signaling mechanism, vehicle-to-vehicle communication, that can allow cars to operate in a way where there is communication, there is signaling happening, such that this car says, hey, make a little more space so the car behind you can get in and follow closely within this tight pack of cars that maybe we're driving in convoy. You're driving from San Francisco to Los Angeles. Maybe there's a dozen or 2 dozen cars that are all making that trip. Why can't they, in a tight pack at very high speed, travel together? Aerodynamically, efficiency-wise, speed-wise, hassle-wise, it seems like that would be better for everybody involved. And that's not going to in any way challenge our ability to go out and have pleasure driving.
Right.
That's just going to take away the drudgery of this one form of driving that we have today that's really not pleasurable for anybody.
Totally. And like in that situation, it's almost like car trains. Like It's like they link up together. They know they're going to a certain destination. The aero advantage, like you're talking about, it's like us talking about like NASCAR drafting packs.
They're drafting, right.
They're going to get better fuel economy or electric economy, whatever they call it for electric vehicles. But you're going to get better range, I guess, in that circumstance and all that sort of stuff. And so I could see the benefits of that. And I mean, think about all the examples of like you're on the freeway or you're in the city and like how many terrible decisions you see like humans make if they make like an illegal U-turn or like all of a sudden they remember they need to go off at their exit and they cut across 4 lanes. Like all these dangerous situations we see of humans making terrible decisions. So autonomy, the robots in that way, are going to help out roadways. They're going to reduce accidents. They're going to reduce congestion. They're going to improve, transport from point A to point B. But yeah, I can kind of see in the dystopian future, like these signs when you get out to like Route 1 or Highway 1 or like whatever a fun driving road is where it's like, take manual control only for this road that like there is no autonomy there. Like you have to know how to drive. And maybe for us enthusiasts, that reduces the traffic in those areas because people are like, oh, well, I actually have to drive if I want to go there. So like, I don't want to go on that road. And like, we can have our little havens of the people that still want to drive their cars.
These things can interact together, right? They can coexist. There is a change that needs to occur to get us to the point where we think we all want to be or where we think we need to be, maybe we should say, which is changes to the infrastructure, changes to the way we drive. And here's the reality. I don't know about you, but I don't think drivers are getting better on the roads.
Right.
They're getting worse. And in fact, we're making this problematic because we're now taking away some of the skills necessary to be able to drive a car by replacing them with technology and safety skills, safety capabilities. So now that you have automatic lane departure technology, now that you have automated cruise control, dynamic cruise control, there are circumstances which people do not have the experience doing the manual thing anymore. How about turning your head around to look behind you if you're going to turn around or you're going to look in your rearview mirror? No, we just look at a camera that's on a screen now. So if somebody who has that experience drops into an older vehicle that doesn't have those capabilities, right, everybody else is going to suffer for it. We've all been on the road where there's that car that hasn't turned on their headlights because they've never driven a car that didn't have automatic headlights and they didn't know to turn them on. And we're all thinking, God, that person's going to create an accident. So there is part of this, which is, yes, as we create more technology, it's actually hampering in some ways humans' individual, personal capability of knowing how to drive a car. And what's going to happen is over time, fewer and fewer people are going to be as adept as the average driver on the road is today as we increase the level of technology and autonomy in vehicles. So there's this sort of joint problem, which is fewer people are going to be driving, fewer people are going to be good at driving, but there's still a core group of individual enthusiasts who want to drive. So how do we coexist? How do we allow for all this to happen and have all our cake and eat it too?
In this introduction or implementation of technology, self-driving technology, whatever you want to categorize it as, now is the most dangerous time because the technology is being implemented, but it's not fully taken over. People are relying on that technology, so they're becoming worse drivers. So it's almost like kind of hurry up and get to that point of full self-driving so those people that suck are safe because the robots can take over, right?
That's exactly right.
And then that kind of split that you're talking about of like, this idea that in the not so distant future that the art of knowing how to drive a car, which nowadays it's like the art of knowing how to drive a manual car is starting to die out.
That's a dying art, yeah.
So like the art of knowing how to drive will become something of like the past, right? Or like unless you're really into it or you're passionate about it, you'll know how to do it and do it really well. I think a great comparison is like what happened when the car got introduced, right? Of everyone had horses. Everyone knew how to ride horses.
Yes.
That was the mode of transportation. You knew how to manage horses, take care of horses. You could get on the back of them, do that whole thing. Like that kind of got phased out and people are like, well, now we have cars, now we have roads. So like that's the main purpose or main deal of personal transportation. But like horses still exist. We didn't kill off the horses, right? The horses still exist. People still have horses. People still ride horses. People still have fun with horses. They are kind of designated to their certain areas that you can do that. It's not like you can walk or ride a horse down the I-5 interstate.
Right.
They're kind of banned from that, but there still is space for them to exist.
They've become a more exclusive thing. They're a leisure time thing. They're a thing that's more reserved for people who have, let's face it, the money to do it, the time to do it, to go be an equestrian, to go do dressage, to go do these things that sound pretty fancy now. It used to be just you grab your horse and you're going to go somewhere, and that wasn't like a fancy or special thing.
Right.
And there was a period where actually a lot of horses were dying because automobiles were introduced and we hadn't yet built out car infrastructure. We still had dirt roads and paths that horses were going down, and that was what we had. And we started implementing these vehicles, these cars, these automobiles, and we were having accidents. Like literally, like people were running into horses. We needed to introduce traffic signals and stop signs and some way to indicate, other than humans talking to each other out loud, like, hey, go ahead and pass by. There needed to be a mechanism, a signaling protocol for this stuff. And eventually they decided, let's build the road with these characteristics. We'll standardize what roads are so that the vehicles can be built in a certain way and we can all have those be there. And little by little, there were fewer and fewer places for those horses to go on those roads because they weren't designed for them. There was, again, that overlap period, but eventually that pretty much has since vanished.
Now, before we get into maybe talking about like what is the changes in infrastructure going to be like now, for not as it changed from horses to cars, but now as it changes from cars to self-driving cars, I think there's going to be some change in infrastructure and what that could potentially look like.
Yes.
I think we should try to imagine what we think the future looks like of how we cater to those autonomous vehicles. But before we get into that, I think it might be beneficial to talk about the different stages of automation. So going through those different phases, where are we kind of at now? And then as we get to that final stage of automation, fully driving cars, no steering wheels, nothing like that, what does that infrastructure look like to cater to those vehicles?
All right, so we're going to talk about levels of autonomy. There's actually a definition of this that's standardized by the SAE, the Society of Automotive Engineers, that classify these variations in the level of sophistication or capability a system would have, from no automation, they call that level 0, all the way up to level 5, what they call full automation. The thing here that's really interesting is there's these gradations where in level 0, no automation, right? The human driver does everything. They drive, they steer, they accelerate, they brake.
That's a normal car.
That's a normal car. It's what we think of as a passenger car, and it's not even cruise control. It's like more basic than cruise control. If you want to go, you're pressing the throttle. If you want to stop, you're pressing the brake. Then there's the level 1, which is they call driver assistance. So that's effectively the lowest level of automation you can get. And that's things like you might have where a cruise control system becomes adaptive. It can change its distance to the car in front of it based on some sensed data, whether that's radar or otherwise.
Yeah.
It would say, keep a gap of this distance or stay at this speed.
It'll set its speed based on how close you want to be to that car. Like radar-guided cruise control would be that. So it's kind of, it's helpful, but it's not doing everything.
Yeah, lane keeping assistance is kind of the other thing that's in this category.
Okay.
It's giving you information. It's like, hey, there's a thing, but it's not actually doing anything about it. Right. Then there's partial automation at level 2, where the vehicle can start accelerating and braking and controlling steering at the same time. But the human has to monitor the environment. So this is kind of like what Tesla's been doing with their autopilot.
The highway system.
Yeah, where you're allowed to have the car take control, but the human has to be behind the wheel and theoretically alert and engaged and able to take over.
Yeah, and I know for Teslas, there's like pressure sensors in the steering wheel where you still have to touch the wheel.
Yeah, that's right.
So you're based on the liability, you're not supposed to remove your hands.
That's correct. And then the next step up from that, they call conditional automation, which is level 3, at which point the vehicle can actually drive itself under certain circumstances only. So if there's a traffic jam or there's that kind of convoy like we talked about, the car can do that. But it still relies on the human driver being able to take over or being able to intervene in some way. The next level is level 4, what they consider high automation. And this is effectively what you'd think of as fully autonomous. This is where the car drives itself. It was designed to do so, and it doesn't require any intervention from a human. However, there might be limitations or specific conditions in which it doesn't completely meet the requirement of being fully autonomous.
So like, I feel like high automation, that might be like the Tesla, like full like point A to point B driving, where it's taking over. You don't have to engage. It's limited areas. So sometimes it might come up to situations it doesn't know, but you're still behind the wheel. There's still a steering wheel. Waymo might even be within level 4.
I'd say that sounds right. I mean, you're still giving it the input and output, right? The source and destination. And maybe there's some other specific requirements that you can give it. Like with a Waymo, you can't do this today, but you can imagine it might say, like you can in your navigation software, you can say, avoid highways or avoid ferries or something like that. So you can imagine where that level of interaction with the system is still allowed.
Yeah.
Whereas in the level 5 full automation, you're talking about a car that can drive itself. I shouldn't even call it a car. It's a vehicle, right, at this point.
Yeah.
It can drive itself in every condition, in all circumstances, scenarios, and environments without any human involvement. So that means you didn't even tell the car, go to this place or change a route. It's going to make those decisions fully on its own.
Yeah.
And it's got to get that information or be able to derive that information from somewhere. And so I think the keys are at the lower levels, like level 0 through 2, the driver is completely in control. And as you go up that scale, the automation takes over and then eventually pushes the driver fully out of control.
I think nowadays we do have an example of level 5, which I would say is the Zooks, the little like the pods, because I think also another distinction of how you can tell if it's level 4 versus level 5 is in level 4, there's still controls for a human. So there's still a steering wheel, pedals. You can still drive the car if you wanted to as a human being. Where like
Correct.
Full automation means no steering wheel. There, you don't even have the possibility to drive the thing if you wanted to as an individual. Like the Zooks is, there's no steering wheel on the inside. There's no option to like control the thing if you needed to. So I think that is the final distinction. So we are to the point of like level 5 does exist nowadays, but it's not super accessible or super widely available, where like most cars that you can buy from manufacturers, those are going to be like more in level 2, level 3.
That's right. And a lot of what we're seeing today that sounds like that level 5 is actually level 4 because it's still sort of geofenced, right? It's only allowed in a specific area, location, circumstances. You can't just drive literally like anywhere you can get in this mode, which makes it level 4 versus in level 5, at which point they can drive anywhere.
But I feel like that's more, I would say like the restriction is more from like a political standpoint of the regulations. Because like the car would be capable.
It would need to be independent under all conditions, which
Okay.
I just don't think our
Okay.
technology is that far yet, right?
Got
I think
it. Okay.
there are political and other sort of environmental overlays that probably prevent that from occurring, but I think it's probably a good thing at this point. And maybe something worth talking about is while we're trying to develop this new technology, and it's super cool, people are taking chances, people are taking risks, and they're taking risks with human lives. And in some cases, certain companies, which we don't need to name, are more cavalier with doing that than others.
Yeah.
And they're willing to push the envelope, to push the technology ahead, potentially at greater risk than other companies who are maybe more concerned with their reputation, the implications of if they were to do harm to humans. So that's another factor that I think maybe varies the rollout of this technology or how quickly it accelerates in that rollout in all of the implementations that we've seen. You know, it's limited by the environment still. And until the environment is created or modified in such a way like we did from the dirt paths for horses into paved roads, until we're at the point where the infrastructure of the highway system is designed specifically for autonomous vehicles for the most part, I think that will be the thing that prevents us from making that jump from the high autonomy to the full autonomy, level 4 to level 5.
Yeah, and I think on top of the infrastructure piece, which I think will be important of like just like repainting lines and stuff or like creating symbols that these autonomous systems can respond to. But I think the other piece that's like why this technology has been so slow to be rolled out is also that liability discussion like you're talking about of like who's willing to take the risk. And
That's right.
Frankly, like if I'm an automotive manufacturer making cars, I'm like, I'm not going to take on that risk. Like, why? Like, I don't want to be the one that gets sued because we're developing a technology, it fails, someone gets hurt, and they're going to come after me. Where, like, I feel like tech companies are more willing to take big risks because it's like, go fast, break things is like the whole attitude to come to technology. And like, they're so excited about the possibilities that they're like, the risk, so be it. Or they have the confidence in themselves to like write the code of like, oh, the risk isn't really there. And I think Tesla, for the most part, was the one where within the automotive space, they were willing to be the scapegoat. And I think all the other manufacturers are like, awesome, yeah, you do that. You go ahead and implement that technology and see what happens, and the rest of us will follow. And I think, for the most part, I think most people don't realize a lot of cars of other manufacturers have the same capabilities of Teslas to do the self-driving thing. They just haven't flipped the switch on because they're just like waiting for this kind of test phase to happen, all this data to be collected, and then they'll go ahead once like everything seems safe and good and no one's getting sued over crashes with autonomous vehicles, then they'll go ahead and jump in.
It's not a good look for your company to be in the news as having run over a kid or a dog or something like that, So most of them are hanging back and trying to get this stuff right first before they go push it out. But there's something else to be said about the culture of the technology industry, which is there are sort of gradations of what I'll say is how serious the engineering is. And this sounds kind of funny, but there's different types of engineering. There's civil engineering, mechanical engineering, electrical engineering, computer engineering. And what we call software engineering is part of that. The reality is civil engineering is things where we build bridges and buildings, and if it doesn't go right, people die. Like the aqueduct fails, people get flooded, and everybody dies. That's pretty bad. We really want to get that right, don't we?
Yeah.
So we're going to build an airplane. We want the airplane to work and not to fall out of the sky and kill bunches of people. So let's get that right, shall we? Mechanical engineering, electrical engineering. You can see where I'm going with this. We don't want to start a fire. We don't want to have there be safety conditions.
Yeah.
We get into computer engineering, we get into software engineering. We're now in a domain where things are software failure modes. We're used to there being errors and correcting for errors.
Bugs, glitches,
reboot, reload, refresh, do whatever you need to do.
Right.
You can't do that with a life, right? So we're at a point where now the cavalier qualities of some of these tech companies pushing the envelope from what they're used to and their DNA coming up doing software, they're now taking chances out in the physical world on hardware, in the real meat space world where we all live, by taking risk the way they would in their software. And fine, if there's a bug, somebody will push a patch or they'll fix it if it gets hacked. But in this case, the real world implications are much greater. And I think it's something where we're well beyond where our legal system is representing our citizenry very well. The laws that we have around technology like this are poor, they're primitive, they're outdated. The people who are responsible for putting the laws in place and implementing the technology and the safeties we need to have this stuff work at scale are ignorant about it. So there's a big gap that we still need to cross in getting from where we are to where we need to be. And to some extent, good for those companies who are out there taking a chance and pushing the envelope a little bit, but we might ask ourselves how far we're willing to push for what gains and how quickly we want to go with all this stuff.
Yeah, there still needs to be control on the other end of, these cars are out there with us, right? It's like we're within the test bed because these cars are on public roads. And I agree with you that, from the political side of the control and the regulations need to keep up. And we've seen this in the past of like most technologies outgrow regulations very quickly.
Yes.
And the process of government is a lot slower than the process of tech development.
Correct.
And so it's like, how do you make sure that things don't run away with it? I think I've been really impressed with, Tesla, however many years ago that they introduced their whole self-driving thing and you need to still touch the steering wheel and all that sort of stuff. I think back then a lot of people were concerned that there was going to be like big accidents and people were going to be naive or not pay attention and cars running away and getting into these big accidents. To their credit, as Tesla was implementing this stuff, there weren't a lot of headlines in regards to incidents occurring. Like there were a couple. I think there was like incidences of some cyclists and stuff like that. But it was kind of few and far between. And the biggest overarching conversation people had is like, if this was humans, there'd be way more accidents than what had occurred. And so it was impressive. I thought it was impressive of given them pushing the limits, being at the forefront of the autonomous driving revolution, that there wasn't these big issues of like moral dilemma situations that we've all thought about of like, if you give a robot a chance of like to kill someone else or kill its occupant, what would it do? We haven't had that sort of thing. And even as the technology has progressed and gotten better and changed and shifted, there's somewhat been a conservative, revolutionary approach to that.
I think that there's been a fair bit of news about these things, right? If you look, there have been circumstances where the self-driving cars did the wrong thing. There have been circumstances where there have been injuries and fatalities even.
Yeah.
By and large, there's a cynical part of me that says, well, for them to make this work, they absolutely have to be thinking about these things. They know going in that would be a really bad look for their company, but they also have really good PR departments who are really good at keeping things quiet when they go badly. And there's municipalities that have all this money on the line of being an early adopter to the technology, and they don't want to go put a lot of bad publicity about the company who might pay them a lot of money, right? So there is some disincentive for there to be wide-scale reporting of these things. And to your point, there are way more car crashes by humans than there are these examples of self-driving cars doing the wrong thing. So that all set aside, I do want to call out, though, that level of concern and care that goes into the engineering of the product really is something that people need to take a close look at. And while Tesla has been very successful in sort of accelerating as a company and pushing these technologies out to the forefront, I think there's a lot of edge cases where Tesla has also been pointed out as not having thought through the full solution, the safety implications of the potential harm to others who aren't in the ecosystem along with them. And I think that's something we all need to take a close look at, because just because the company or the people have the most money doesn't mean theirs is the solution that should be the one that wins. And right now we have very many circumstances where there are companies that are worth way beyond what their intrinsic valuation should be because of people investing in stock market dynamics, but like they're not actually as sophisticated in capability as their market capitalization might have you otherwise think. So just because they're the biggest company doesn't always mean they're the one out there with the best interests in mind overall. And I think that's something important to keep in mind. But we should also not get too hung up on this to the point where we don't allow ourselves to have nice things because there are potential risks or concerns, right? It's finding that middle ground of making progress, but still taking into consideration the well-being of all of the people who operate within this space.
And the revolution is far from over. Like we talked about of where we're at in the stages.
Oh, yeah.
There's still a long way to go with this whole autonomous vehicle thing. And I think, like you're saying, it's really important to keep in mind the safety of everyone involved. And once again, we still probably have like half the race left over here. And it's like, don't ease up on the concerns of making sure everything's safe, that we're not going ahead too quickly, too soon, or being too experimental with people, making sure that these companies are still going through the proper tests and training, and they're allowing their systems to learn and experience doing things wrong,
right,
in controlled and safe manners.
Yeah, I mean, move fast and break things sounds great if you're brash and hip and you're writing some software that people use in their free time and it doesn't really mean anything to anybody. But it sounds really crass and really thoughtless when you're talking about people dying because somebody didn't think about an edge case that they could have programmed into the code and then they just didn't, right? So there's a big evolution in the culture that needs to happen here too, in the people implementing the technology, building these systems, and hopefully the laws that get put in place that wrap around all of this in such a way that allow us to actually survive it, manage through this rollout of technology that sure makes a lot of companies a lot of money for the purported benefit of humanity. But at the end of the day, how do we know if it's actually doing that? And to loop this all the way back around to the beginning of the conversation to our Waymo ride. So I've been in the Waymo now a few times. I was emboldened by my first experience because it was actually so positive, more so than I expected. Well, this other experience I had, I was riding, in the Waymo through downtown San Francisco near Union Square, if you know where that is. It's a very congested, dense set of streets, much like you think of an urban environment in like a New York City or a London or something.
There's a lot going on. People are double parked. There's delivery trucks. You got to go into oncoming traffic. There's a lot of, potentially complicated situations.
Yeah, probably one of the harder circumstances for an automated system to figure out what to do.
Yeah.
Certainly harder for a human to figure out. I mean, we're all a little bit more on guard and intimidated by those circumstances as human drivers.
Yes.
So we know that there's something that's going on. Well, in this case, the Waymo was coming up on an intersection where we wanted to make a left turn. And in this particular section of the road, there's 2 left turn lanes, such that the 2 lanes that exist going in a single direction can turn left, and there's a 3rd lane that would continue on straight.
Yes.
So we were in the right hand of these 2 lanes, so the rightmost left turn lane, if that makes sense.
Yes.
Okay. So as we're approaching the intersection, it becomes pretty clear that there's a lot of congestion such that this intersection is backed up. And the Waymo suddenly accelerates and gets on it in such a way that it's trying to beat the car that's on the left of us in the left turn lane to the intersection to like cut it off or something. I couldn't quite figure out what it was trying to do. So it shoots the gap to get to the intersection, at which point now it's too far. It's gone too fast, too quickly, and it's run past the intersection such that it can no longer make the left turn. and we're having to go straight ahead into traffic, which is fine because it's a one-way road. But this was supposed to be a turn lane. And the car accelerated too much to try to get the advantage to make the turn that it overran the turn and it didn't know what to do.
It had to like bail.
Yeah. So the car was kind of stuck on the left side of the road going straight next to parked cars. And we were near our destination at this point, but not quite there yet. And it sort of just gave up. And it pulled over to some cars and double parked and says, "You're at your destination," and like kind of let us out. And at which point we were sort of terrified because the actual movement in the car was sudden. The acceleration was rapid. It was clear that something changed and then suddenly changed again. It didn't leave us feeling super confident. We were like, yeah, we're fine getting out of this one. Thanks. And I guess walking away from it, the hope was that whatever it had learned from that circumstance will be fed back into the system such that whatever it learned to be more aggressive going into that circumstance, it's now going to get the feedback, hey, that didn't work. That didn't achieve the intended target. You did not achieve your goal. When you do that next time, don't do the same thing. So that's how these systems work in the real world and how there is this trade-off of the planned route, the existing map, the GPS, the data that we had going into this thing, and then the circumstances at the moment, at the time, given physics, given the fact that the car accelerated to the point it was past where it could actually brake in time to make the turn, and it had to make an evasive maneuver, which I'd never seen a Waymo have to do before, let alone being in one while it was doing that.
Really interesting circumstance. And I mean, like, that's the benefit of these models and what these cars are going through is that they learn over time. And that's what they're trying to simulate of the way that we work and we think as humans, because I'm sure that we've all experienced that of like, oh, I'm going to shoot this gap to make this exit, and then a gap never opened up, and you're side by side with someone and you're like, I mean, I could either force myself in and cut them off or like give up and just take the next exit.
Right.
We've all been in that situation of like, damn, I missed my exit because I was trying to be too aggressive.
Absolutely.
And we learn of like, all right, maybe next time, like if I come up to this same exit, I'm just going to bail off a little earlier, slow down, find a gap sooner, and just make sure that I don't miss the turn that I need to make.
Yeah. And one other advantage, though, is this system has a hive mind, right? So every single car out there collecting information, learning from its individual experiences, then feeds all that information back up into the cloud.
And it goes to every Waymo.
And it goes to a centralized system that analyzes it, and then it pushes it back out to every Waymo. So as soon as one Waymo learns, at whatever the cycle is of pushing out data and pushing data back in, it probably happens at least every couple of days, if not every day, multiple times a day, multiple times an hour, who knows, that all of the cars are going to learn. So there's this huge benefit on a scale that we as humans can't even fathom because humans can't even communicate at that speed. We couldn't even tell all the other humans, yeah, when you get up to the corner of Columbus Street, don't make a left, the left turn light is out.
Yeah, and the thing is like as a hive mind, all those other cars, in a way, feel like they experience that situation themselves, right? Because think about it, as humans, if I explain to you like, hey, I came up to this intersection, I like try to be more aggressive than I should have been, and it didn't work, you'd be like, yeah, but you probably did something wrong.
Yeah, as far as they know.
And you don't feel it, right?
That's just truth as far as they know.
Exactly. And they just know, right? And as humans, imagine if like every time someone made a mistake on the road, we all learned and got better. Like that would be insane of like how quickly we would all become better drivers.
And then the clouds part and the sunbeams come through and everybody starts singing and dancing because we're all getting along, and it would be such an amazing thing if people would just learn on the roads. It would be so amazing.
If we all got on the same page one day.
Man. Well, maybe we could learn from the computers and figure out a way to do that. But there's a real potential for this to work out well, for this to be a good thing. And so as car enthusiasts, as motorsports fans, as people like to drive a car fast on the racetrack, this sounds really scary, and it sounds like they're going to take away our toys. But the reality is this is something that will enable a different mode of interaction with these vehicles, that'll enable a lot of people who really would have nothing to do with a car if they could help it, and it'll allow them to have that reality. And maybe the future is one where what we think of as an HOV lane, that becomes the automated lane.
Yeah.
And then maybe it becomes the automated level 5 lane. And now there's an automation level 4 lane and a level 3 lane. And human drivers are allowed in the number 3 and 2 lanes, but only fully automated drivers are allowed in the number 1 lane. But you know what that will leave? The number 5 lane, which is for all of us human manual drivers still out of our cars trying to control the things. The reality is, though, there's going to be a lot less real estate for that.
Yeah.
It's going to be way more expensive to do that. It's going to be a lot more like riding a horse.
100%. I think, slowly it's going to get pushed out. Now, This has been a fun conversation talking about like autonomy. What's it like out in the real world? Where are we at now? Where is it potentially headed? Now, to get a little bit darker and cynical maybe in a future episode, let's think about if they start taking things away from us as car, motorsport enthusiasts. Is there a place for autonomous vehicles within motorsport? Because we always talk about motorsports as this place, this proving ground to develop things, whether that's hybrid technology, tire technology, brake technology. Racing cars, especially endurance racing and stuff like that, is a great way to develop things that then get passed on into road cars. And if this is a new technology that we're going to see out there, is there a space for it in motorsports, pushing the limits, pushing these codes and algorithms of the autonomous driving AI programs to the limit? Does that make sense? Is that feasible? Is it happening nowadays? And we'll dive deeper into that into a future episode.
Yeah, there's enough overlap there. I think we want to be safe in motorsports and on the roads. We want to be efficient in motorsports and on the roads. There's a number of different things about driving that there's commonality here. And I think there's a lot of good things that we can exploit from it. Yeah, and there's differences and things to be fearful of, and we'll talk more about that. But I think automation in motorsports is a fascinating thing. I think
it's a wild crossover.
Yeah, I mean, as a kid, I remember playing the video game, the robot football game, and you're like, can you imagine someday you go to an arena and there's actually robots playing football against each other? Wouldn't that be like the coolest thing ever?
Yeah.
Right? And now imagine you go to the race and you show up and you see the cars pulling up on the pit and there's not a driver in it.
It'd be interesting to talk about, like, does that go over?
Yeah.
Would people care?
Or would that be boring? You're watching a computer program.
Right.
But I don't know. A lot of people watch people play video games.
We'll dive deeper into that into a future episode and kind of diagnose and see if that's viable. Because I think it's an interesting conversation, especially with like pushing the limits of a car, of like how complicated that is as a human. How do you translate that to a computer?
Yeah, and it's out there, right? There's universities and kind of upstarts that are nibbling around the edges in the space. So I think there's enough here for us to take a deep dive into this and explore this world of automated motorsports. That sounds pretty cool. Or maybe really scary and something we don't want to have anything to do with.
Dystopian future, for sure. But that's for a future episode. In the meantime, this has been a great conversation talking about cars driving themselves.
Hey, thanks, Sylas.
Thanks, Todd. And thanks for listening. This has been Cold Start.